IPv4 is only 32-bit size. See, for the entire world, only 32-bit address. Is that sufficient? No. Why? Around like 20 years before, 20 years before, only rich people were having computer. Because one simple computer, very slow computer, on those days that was the biggest computer 20 years before. It was costing around 2 lakhs. You know the capacity of the hard disk of the 2 lakh device? 20 GB. 20 years before, I bought one computer for 2 lakh, and the biggest hard disk in the market was 20 GB. Today, biggest hard disk is in TBs, many TBs, 5 TB, 10 TB. So just 20 GB hard disk. You know the processor, sorry, the RAM size, only 2 GB. That's the biggest computer, fast computer on those days. And the processor was called as P1, P2, P3. No Intel, no Celeron, nothing. No AMD. It was Pentium. P1, Pentium 1, Pentium 2, Pentium 3. And very few people were having computer. So that in those days, it is okay to manage with NATing. You can have this IPRS, 32-bit IPRS, and you can manage with NATing, and you can do. That's fine. But today, you know, one person has got at least 3 IPRS today. One IT professional needs at least 3 IPRS for one single person. And those days, for the entire house, one computer is very difficult to see. And those days, for the entire house, you need only one IP address. But today, in a home, everyone has got one cell phone. So each cell phone needs an IP address. And some have got a laptop. They need IP address. Some people you may not see them in India. Some people I have seen, they have IP address on switchboard, doors, geysers. See, MI company. They provide you a smart home. You can connect your lock, your door. You can connect your geyser. You can connect cameras. Everything to IP, so that you can unlock a door from your office. If a guest is coming to your home, you can see them through IP camera, and you can tell them, okay, don't worry, I'm opening the door. You can go and take rest, and you will open the door from office, and the door will open there. After they go in, they lock, and you can monitor what they do inside the home. You can even turn off and turn on geysers, refrigerator. See how many IP addresses they need for their home. For every single appliance, they need IP address, because they want to individually control. So individually, you need to have an IP address. So the growth of network is drastic, very fast. But the 32-bit has never grown. So what happened after a point of time? There is no enough IP address to give. So what they did, they came up with a lot of other versions. At last, they settled with a version called version 6. There is no version 5. Version 5 is gone. It didn't become a standard. It was simply in the transit in the middle they did, and then they discontinued it. So IPv6 is, after a lot of testing, they have decided to use 128-bit. IPv6 is 128-bit size. With this 128, can we meet the need of the entire world, the IP address need? Yes. The entire world can be satisfied with this 128-bit. So 128-bit is very, very, very big. 128-bit can provide millions and millions and millions. I cannot say how big, very big. How big? See, according to today's technology growth, you will be able to only consume 5% of the address. Remaining 95%, you don't know how to use it because you don't have that much need today. That much is IPv6 bigger. Only 5% you can utilize. So it's very big. Now, this IPv6 is 128-bit divided in two equal half, 64-bit and 64-bit. This first 64-bit, we call it as global prefix. You remember we used to say network portion, host portion in IPv4. So instead of network, we call it as global prefix. And here, instead of a host portion, host address, we call it as interface prefix. Interface prefix and global prefix. 64-bit, totally 128-bit. You see, just the network portion alone is many times bigger than your IPv4. It is not simply double the size. No, it's not double the size. See, 32-bit, if you make it as 33, then it is double. This is 64. I want to prove you that. Listen. I have 3-bit. What is the face value? 111. 7, no? 4 plus 2 plus. If I just add one more bit, what is the value I get? Hello? Look at this. It is doubled, no? So if you make 33, it is double. This is not 33, 64. Very big. Network portion itself is very big. Interface portion itself is very, very big. Very big. IPv6 is very big. That's why I say you will be only able to consume 5% of IPv6 address. IPv6 is too big. Right. Now, this IPv6 address, it is written in hexadecimal. Hexadecimal. So you have 4 bits and a colon. 4 bits and a colon. 4 bits colon. Three, four, five, six, seven. That's all. So you will see 8 groups of 4 bit. Hexa, no? So each hexa bit is 4 binary bit. So this is 16 bit, 16 bit. Likewise, you have 8. 16 multiplied by 8 is what? 128. 128. 28. Now, you may think like, what is this? IPv4 is only 32 bit. Now IPv6 is 128 bit. Won't this take much time for the process? See, in every packet, there will be source IP address, destination IP address, correct? If it is 128-bit source address and 128-bit destination address, won't that be difficult for the routers to process? Uh, I agree. Comparatively, yes, it takes a little bit extra processor, but you know, IPv6 is much faster, less process utilizing. It will consume only less process compared to IPv4. How? Compared to IPv4, even though the IPv6 address is 128 bit, if you take IPv6 header, there will be 128 bit source and 128 bit destination address. Whereas in IPv4, you will have only 32 bit source, 32 bit destination. But still, this is faster to process, less time is taken, and this is longer. How? It is because of the simplified header. Simplified header. Meaning the header, the IPv6 header will have only necessary field, only reasonable field. Whatever is needed will be there. Source is one field, destination is one field. Likewise, version, and then uh, TTL. So only necessary field will be there. But in IPv4, even those fields that are not necessary now, it may be needed later, but not now. Even all those fields will be there. Always all fields will be there. In IPv4 header, you cannot add any field that you want, you cannot remove any field you want. It is fixed. So you have to carry everything all the time. But in IPv6 header, whenever you need some extra field, you can add it. If you don't want it, you can just remove it and have only the necessary field. But in IPv4, all the fields are always there, whether you use it or not. So what happens when a router receives a packet? It will check these fields. Oh, nothing is there for me to, only garbage values, only garbage values, only garbage values. So unnecessarily it is reading all the garbage values. And there may be some interesting information like IP address, but rest of the fields are not always used. So IPv4 is lower. It takes time because the number of fields in IPv4 header is more compared to IPv6. You understood? Did you understand what I said? Okay. So IPv4 is lower than IPv6. It is because of the header. Even though the IPv4 address is small, the amount of bits and bytes that need to be processed in IPv4 header is too much compared to IPv6. IPv6 header is simplified. Next, this IPv6 address, even though it is this big, even though it is very big, you can write it in a very simplified way. How? Let me show you. For example, the IPv4 address is this. Sorry, IPv6 address is this: 2000 000 000 colon 000 0001. Let's say this is the IP address. You don't need to write this big number. You should write this 2000, and all these consecutive zeros, you can just put one colon, that's all. And then this leading zero has got no value, so you put only one. That's all. This is equal to this. You can easily write IPv6 address by omitting those consecutive zeros and leading zeros. Those consecutive zeros, you can just put colon, colon. And then the leading zeros. See, can I remove these zeros? No. If I remove, what will happen? It will become 2, not 2000. But if I remove this leading zero, is there any problem? No. Always it is 1 only. If you have that 0 also, what is the value of this one? 1. If you remove the 0 also, it is 1 only. Correct? Yes or no? So leading zeros can be avoided. So this is how you can say subnetting and all. Here it is not like IPv4. There is no subnetting like IPv4. IPv4 subnetting is difficult. Here IPv6, I said this is network, right? Now, if I want to do subnetting, I need to just put one number here, like 2000 colon 000 colon 000 colon 0001. This is one subnet. You understand? How easy is the subnetting? This and this is not same IP address. Why? This is the first IP address of the 0th subnet in 2000. This is the first IP address of the first network in the 2000 network. Understand? So subnetting is very simple here. Fine. Now you see, how can you shrink this one? How can you shrink this one? I said consecutive zeros, you can put colon, colon, but you cannot put twice. So you can write like this, 2000. You can either shrink this with colon, colon or this. I'll go with this one because this is bigger. So for this, what I'm going to do, I'm going to say 0 colon 0 colon, and then this leading 0 I remove and then I put 1. See, I just put for this 1 0, for this another 0. And now for the entire thing I can put colon colon 0, sorry, not 0, 1. That's all. That's all. So you cannot put this one 2 times, only 1 time. You do it for this or for this, whichever you like. Okay, so this is how you can shrink the IPS. Now, always you will see IPv6 address starting with 2000. You know why? Because in the year of 2000, this IPv6 became standard. 22 years before. What is today? What year is now? 2022. In the year of 2000, IPv6 became standard. So we will see all IP address starting with 2000. All right. We call it as global unicast address. What? We don't call it as public IP address. Global UNO. And then there is another address called link local address. This address you no need to assign, it will dynamically get assigned. And this will be always starting with FE80. You no need to again worry about this address. This address is for neighbor discovery. This address is for discovering the neighbor, and this address will be dynamically generated. There is another address, multicast address. Multicast address will always start with FE. Wait. FF02 : for example, what is the IP address, what is the multicast address of OSPF? What happened? Why you are 224.0.0.9? No. 5. OSPF is 5. Okay. So 220 instead of 224.0.0, you need to put FF02 : 5. This is for OSPF. Tell me what will be for EIGRP? FF02 : A. Why A? A means 10, right? In hexa, A means 10. EIGRP is 10. Now, what is that for RIP? FF02 : 9. So, all the multicast address will start with FF02. Okay. So, these are the three type of address. There is also one more called Anycast, one to the closest that you will see when you come higher. So, Anycast address is for the closest, which is a new type of address that you will see in IPv6 that we'll see when we come to CCNP. Now, what I'm going to do is I'm going to take two router and show you a small demo in IPv6. So I'm going to create loopback interface. It's a logical interface, right? I'm going to create a loopback interface with 1/1/1/1/1/128. What is this 128 means? Mask. You got it? So I'm going to, even though IP address will start with 2000, this is lab environment. I can start with 111, it is okay. And here I'm going to say 2000 : 1/64. What does the 64 means? 64 bit is the global prefix, is the network portion, mask. 2000 : 2/64. And then loopback I'm going to give 2222 : 2/128. Now I'm going to configure this and show you pinging. RA and RB. Right. So we got these two routers, and I'll connect a wire between them, and then You do one thing. We'll do one thing. Let us take one computer instead of loopback. We'll ping between this computer to this computer using IPv6. That's our task. So the IP address that I want to use here is 2000 colon 1 colon 1 slash 64. Okay, I changed my mind, so I'm going to use this. Let's connect a wire. Right, and then here we are going to give 2000 colon 3 colon 1 slash 64. They are not same network. This is 3 network, this is 1 network. And here I'm going to give 2000 colon 2 colon 1 slash 64. Here 2000 colon 2 colon 2 slash 64. Let's begin our configuration. Have a close watch. I'm going to configure on the computer. Going to the desktop. This time we are not going to give IP address to the IPv4. We are going to IPv6. See, I told you, link local address will be automatic, starting with FE80. See, FE80 link local will be always there. You don't need to worry. So now I'm going to give 2000 colon 1 colon 1 slash 64. Sorry, slash you need to put here 64. Got it? Now you can verify. Verification is IP config only. Sorry, IP config all / all. You can see IPv6 address that we configured should be this is a simulator. It's not showing. It's not showing, It's not showing. But we have configured. It is there. It's a simulator. It has got limitation. And the gateway is going to be 2000 colon 1 colon 2 slash 64. So this will be the IP address on the. I should not put colon slash there. 2000 colon 1 colon 2. So this is the IP address on the gateway. Means router. Let's try now. Sorry, this simulator is not showing proper. Anyway, we'll ping and check later. So this is going to be what? 2000 2 slash 64. Likewise here 2000 colon 3 colon 2 slash 64. All right. Now let us finish this computer. 2000 colon 3 colon 1. Here we need 64. And here we need to say 2000 colon 3 colon 2, which is a gateway. We finish configuring. It shows only the link local address. Surprisingly, it's not showing IPv6 address. Anyway, not a problem. Let's go. That's the limitation of simulator. Let's go to the router. On the router, host name router 1, interface F0/1. What is the IP address on 0/1? 2000:1:2. IPv6 address. That's what you need to put. IPv6 address 2000:1:2/64 and no shutdown. Next, what is the interface? Interface F0/0 no shut. IPv6 address 2000:1/64. Yep. Now let's verify. Please have a close look. Show IPv6. Listen, it's not show IP interface brief. Wherever you put IP, you just put IPv6. That's all. Show IPv6 interface brief. Look at this. Did I configure link local? See, it's dynamically given. Fine. The interfaces are up. Only this interface is down because the other side of the router is not configured. Let's go to the other side of the link. Host name router 2, interface F0/0 no shut, IPv6 address 2000:2/64. Interface F0/1 no shut, IPv6 address 2000:3:2/64. That's it. Show IPv6 interface brief. Look at this. Now, if I ping the directly connected 2000:1:1, immediately it will ping. Oh, not 1, sorry, 2. Directly connected is 2, no? I put 1. For 1, we don't have route, you see. Show IPv6 route. Do you have route for 1 network? 2000:1, we don't have route because it's not directly connected. It is behind the router 1. Anyway, I can ping very easily 2000:2:1 because it is directly connected. Now, if I want to ping from here to here, are you listening? If I need to ping from this PC to that PC, what is needed in the routing table? Route. Yeah? Router 1 don't have the route to reach. Yeah. There is no route to reach 2000:3 network. So I want to show you just enabling a RIP protocol in IPv6. All other protocols we learn in CCNP. IPv6, other routing protocols we learn in CCNP. Here, I am showing you RIP. Are you ready for that? Listen. You need to go under the interface. But before that, I'm telling something. Just create one loopback and put one IPv4 address. You know why? If you put like this, IPv6 will use this as the ID. For every router, there is a need for an ID. Okay? You need an ID. Even though it is an IPv6, you need an IPv4 address ID. Now, let's see how to enable RIP. Interface F0/0, IPv6 RIP. You need to give a name. Kiran enable. Oh, you know what happens? It says the routing is not enabled. How to do that? In the global mode, you need to type IPv6 unicast routing. Please understand, before you start configuring any routing protocol, you need to configure this command. You understand? Now go back to the interface and put this rip command and another interface F0/1. Finished. We have enabled rip, IPv6 rip. See, there is no network command in IPv6. Now let's verify. Show IPv6 protocol. You see, you have an IPv6 routing protocol called RIP, and the RIP name is given as Kiran, and these are the two interfaces in which it is running. You understand? Now go to router 2. As I told you, just create one loopback interface with IPv4 interface loopback 0. We are not going to use it. The protocol will use it as a router ID. Okay, next is what is this? .255. Okay, now IPv6 unicast routing interface F0/0 IPv6 RIP. You can give any name. There you gave Kiran. Here you can give any name. What name you want to give? You want to give Earth. Enable. Interface F0/1 Earth. This name is local. You got it? Now let's verify. Are you ready for the verification? On router 1, show IPv6 route. You see, you have learned this route via RIP. Can you see this? And the next stop is the link local address starting with F80. More about it is coming in the next level of training. Now you see, I can ping from here 2000:3:1. It's pinging. And you see, it's very fast. Only first packet took 2 milliseconds. Other packets are very fast. It is very fast than IPv6. It's very fast than IPv6.